Hello and welcome to this video, number 5 in the series on testing a serial MRAM. To be more specific, it's this Avalanche device running in the SPI mode, and we'll be testing it using a high-level technology Griffin 3 test system and the Symphony 3 software. So what about timing measurements for our DUT? The Griffin 3 can do that in the AC Parametrics window. First, you need a functional test pattern that you know will pass, and we have plenty of those for this Avalanche serial MRAM. Like with DC Parametrics in our last video, you define tests here by using the device specs for AC timing characteristics. The types of tests that can be done are access time, setup and hold time, measure pulse width, or custom. This memory device doesn't really have an access time, but we use that test type for prop delay. It's virtually the same thing. It passes, and the test is pretty fast. The results you see are also saved in a log file every time you run the test. How does a G3 do this? Is there some special instrument inside? Actually, no. We use the timing generators to do it. The tester's internal 32 timing generators are used to define edge placement and to compare strobe the data on the output pins too. One timing delay generator is used as the reference time, and another delay is used as a variable. The variable will sweep across a range of time that you define by using the device spec. In this way, we measure the worst-case result through the entire test pattern, which guarantees that if the result is a pass, it will pass for all valid conditions. Our prop delay test is called TOC, the name of the expected output delay value from the spec. See in the pin setup window, we are using timing delay number 6 for our clock trailing edge. So that is what will be our reference point. Our variable is going to measure output valid, so we use the compare delay, and that is delay generator 1. However, we're going to use delay number 2, which is not being used by any other pin. We must select the output pin, and on this device it is DUT pin 2, named SOIO1. We are using the full measure mode, so we get an actual measured value, rather than just a pass-fail result. Now with this test defined, we can add it to the auto test suite that you have seen in earlier videos. If you haven't, just go back and watch this series from the beginning. You'll be glad you did.